the Chinese Lunar Exploration Program. The symbol is meant to vaguely suggest the Chinese character for moon, which is, in fact, among those four characters below it, that's actually that one right there. That means moon. But the other part of this is symbolic, is those are supposed to be human footprints, indicating human footprints on the moon. Now, of course, they can't really be real footprints. Your feet would be destroyed instantly from the cold. So maybe that's why they're so fat. They're in boots. Which reminds you of the old Space Force show where they were talking about landing on the moon, and the general says, "We want to see American boots on the ground with American feet in them." Well, they want to see Chinese feet in them. The first two characters are China. It's Niddle. The first character is Niddle, and the second one is country. They always thought of themselves as the center of the world, and that's kept up ever since then. Okay, so early launches. Going back to 2007, they've been doing this for a while. Now, so far, they've all been robotic. Of course, that's going to change in the future. They have a whole program series named after the moon goddess, Chang'e, and they've been improving the capabilities over time, and also doing a lot of other exploration. After they dropped off an orbiter around the moon, while they're at it, they had some extra fuel. They decided to go over to the Earth and the Sun, L2. They just moved around, they went and they did an asteroid flyby, and then they just went on to deep space. So they're getting good use out of these craft. They finally did land. 2013, they had a lander and a rover, and that was on the near side of the moon, being the part that you can always see, the northern hemisphere. And then they had a test really for future landings where they wanted to make sure that they could actually return samples to Earth. So they didn't actually go down and land and take a sample, but they did everything else. They sent the capsule back. They made sure that they could get it back to Earth and recover it. So they tested all that out. And then they put up a communications relay. They needed that because they wanted to land on the far side of the moon. So if you're on the far side, you can't have a radio signal going directly back to Earth. So they thought about that. They figured out what to do about it. And here's what they came up with. Actually, the idea of a halo orbit, there's actually a lot of early American literature about that. It's not a new idea. They were actually the first to do one, though. That was one thing that's different. Let's start on the right-hand side of this diagram here. So you got the Earth where the monitoring stations are. You got the moon, which is rotating around the Earth. The moon is going in a circle around that, flat on that screen. So the near side always points to the Earth. The far side never points to the Earth because the moon rotates just exactly at the right speed to make that happen. Now, there's a point called the Lagrange L2 point, which is out here on the far right-hand side, where you can have an object like a satellite moving at the same speed as Earth, the rotational speed. So it kind of looks like the left-hand side here, where say you got the Earth in the center, you got the moon in that circular orbit. You draw a line between the Earth and the moon here. And there's Lagrange point 1 and 2. 1 is where there's exact gravitational balance between Earth and the moon. And it's easy to see that one because you can imagine if you just got a little closer to the Earth gravity would start to win out and it would pull it away, or vice versa going to the moon. But you have a similar kind of thing going on where normally you expect if you're farther away from Earth, you'd expect the orbital speed to be slower in angular velocity in particular. But it's not. And the reason is you have the extra pull of the Earth, and that's maximized right along the line between the Earth and the moon. So that's why it's pulling it along. So that L2 point, that's quite strategic because you can't transmit anything there. The moon is always in the way. However, if you have one going in a circle around it, or back to the picture on the right-hand side here, they put the satellite in an orbit around the L2 point. Now this is an orbit perpendicular to that screen. So you're far enough out, as long as you're up high enough, you always have a view of the Earth. And that's what's shown in these green lines here. You know, no matter where you are, that satellite can always communicate with Earth. And that's why you put it out that far. Now, you can't necessarily communicate with everybody on the far side because at some point the curvature of the moon gets in the way. But, you know, you can cover most of the moon anyway. So that's what they did. And actually, the Lunar Gateway is going to be in one of these kinds of an orbit as well.
There was a question. Is there a gravitational pull towards L2?
It doesn't really get pulled, but it takes minimal fuel to do it.
One of the attendees brought up the representation of the forces like gravity on the satellite as a bowl. The easiest orbital path is to fall down into the bowl, but that would imply that the orbits around the Lagrange point are stable, and a satellite would eventually spiral into the Lagrange point. That's not the case for L1, L2, or L3. As we discussed for the L1 point, for example, if you get slightly off of L1, you get pulled more towards Earth or the moon. There's a balance of gravity exactly at L1, but it's not stable. Think of it more like a ball balanced on the top of a very sharp mountain peak.
Yeah, it's not quite that simple, though, because that's true for the L4 and the L5 points. They're actually stable. Meaning exactly as you described. If something gets off of it a little bit, it'll get pulled back in. And that's why they have all those asteroids collected that what are called the Trojan points around Jupiter.
L4 and L5 for Jupiter's orbit of the sun.
You go out there and there's just a whole pile of asteroids that kind of all accumulated there. They just collected it. And there's two of those, there's L4 and L5. It's more complicated here. You can drift off, but it still takes very little energy to. So anyway, the big advantage of that orbit is never blocked from Earth. And you can cover most of the far side of the moon with doing that. Okay, so Chang'e 4, that one actually had a lander and a rover. That was the first one that did that. And that was in the South Pole region on the far side. So they had a lander and a rover. They didn't have sample return as part of this project. But anyway, it looks like that. There's the lander on the left side. The rover rolls off. Now, as far as the landing site, this is a picture of the moon on the left-hand side. This whole area where they landed is called the South Aitken Basin. There's a bunch of individual craters inside that, shown in more detail on the right-hand side. But the point is, you're not actually at the poles. But everybody's kind of interested in the poles just because there's a whole variety of reasons for that, like availability of water. So everybody's focusing on that. And even back then, they were trying to get relatively close. So Chang'e 5, now it is an orbiter and a lander. And this also this is the ascent vehicle, so it looks a little bit different because they took samples. They didn't have a rover in this case. They just took samples directly. I think it could go down like 6 feet or something. Drilled a bunch of samples fairly quickly and then returned. And so this is a fairly elaborate operation. You got to go up, you meet back up with the orbiter. The orbiter then heads back to Earth, and then it drops off a sample capsule. It's pretty much actually a lot like the Apollo missions went. It was a similar kind of an architecture. But anyway, them doing that, the point is it's a fairly elaborate kind of thing. They did it. They managed to take samples back from the moon. I would add, by the way, the United States never did that. We did it with people, but we didn't, which is a whole lot harder in some ways because of all the life support issues. But actually to do it in an automated fashion like that, that's actually pretty impressive. The satellite then they were using before, I talked about being in a halo orbit. Well, they rethought that after their experience. The problem is it still takes fuel to maintain that orbit. So the new one, which is Chang'e 2, is bigger, it's more powerful, but they have the same issue. They want to get communications with the far side of the moon. They just have a bigger one. The antenna is the same size, but everything is more powerful otherwise. Everything's bigger. And they also sent up a couple of smaller test satellites. Long term, what they want to do is they want to have a network of communication satellites so they can communicate with their rovers and their landers and everything on the near and the far side of the moon. So they're setting all that up. So its orbit is different, though. They just went for a very highly elliptical orbit. And this is not to scale. If that were to scale, it wouldn't fit on the screen because it's like a 200 by 16,000 kilometer orbit, like a 1 to 800, meaning if you were 1 foot wide, it'd be 800 feet long, and it doesn't fit. So they had to take some liberties in this picture. It ends up with a 24-hour period. I think it starts off with 12. But anyway, the point of an elliptical orbit is that basically you spend most of your time, you're going very, very slowly when you're farthest from the moon as it goes around. When you come in, you start going really fast. And you can kind of think of that as a trade-off in kinetic versus potential energy if you've had some physics. That basically, you go up high, you don't have as much kinetic energy. So that's desirable because
you may be far away, but you can spend most of your time over a target area.
There's no atmosphere in the way, so the distance isn't so much of a problem. The main thing is just being able to loiter there. So you're going kind of slowly. So that's what they're going to do. And the reason they like that is not only is it elliptical, this is what's called a frozen orbit, and that matters especially in the moon. Frozen means it's stable. And on Earth, it's not so much of a problem, but on the moon, it's a big problem. You have big variations in the density from place to place. They call it mass cons or mass concentrations. And they found actually the low lunar orbits, they're almost always going to end up crashing. They get disturbed so much just from going over these really concentrated masses. But they found a few that are they're frozen that will last essentially, maybe not forever, but for a really, really long time. But basically that any perturbations kind of cancel out. You get pulled one way, well, then you get pulled the other way, some other part of the moon. There are 4 known circular lunar frozen orbits. They found that out back in about 2006, just partially by experiments and then I guess partially by math as they got a better feel for the topography and the gravity. They've been having orbiters around the moon for a long time, and they've been measuring a lot of this stuff, like what is the local gravity? It's not really fixed. You think about that. Earth is less of a problem because you have tectonic plates, and you got biology and wind, water, everything kind of tends to relocate the mass quite a bit. And you don't have any of that going on the moon, and that's why you have much worse problems navigating there. So anyway, there's frozen ones, but that's for circular. For elliptical orbits, somebody else did a study about the same time, figuring out where some of those would be, and they picked one of those. where they think they're going to minimize propellant use. They hope not to do any orbit corrections for the next 10 years. Unlike the Chuichao-1, the first one, is in the halo orbit, which is kind of unstable. They need to use 80 grams of fuel for correction every 9 days. Now, 80 grams may not sound like that much, but over a period of years, they run out. So they decided to go for that. So what's coming up? Well, they're going to have a lander with an ascent vehicles and sample return. This is far side. So they're doing sampling from the far side and returning. So they're kind of putting it all together at this point. They're pretty big. It's about 7,000 pounds on the lander. 1,500 pounds of that is the ascender. The science payloads, they're not really all just from China. They have France, Italy, Sweden, and Pakistan all contributing instrumentation or various parts to this thing. All of these return about 2 kilograms of samples, 4 pounds, from the surface and from up to 2 meters below the surface. That's coming up in May. They had just launched that communications satellite. That's in place, that's working now. And now they're going to do the lander in May. What's coming up beyond that is putting more of it together. This time they're going to have a flying probe or a hopper. And not only will they be taking samples and having rovers and things, but then they'll actually jump around from place to place. They can jump down into a crater, for instance, places you couldn't really drive. So they're trying to expand what they're going to be able to do and return the samples as well. And then they're going to get a lot more serious about, okay, what do you really need to do to establish a base on the moon? They're going to do a lot more lunar science kind of stuff. They're going to do a lot more surveying to figure out what the materials are. They're going to try 3D printing of a structure, that's a real deficiency of the US programs. We're not really thinking about actually living on the moon so much. We're just thinking mainly about going there for a short period and coming back. They're making much more of an effort to figure out what do they really need to do to establish a true permanent base on the moon. And their goal is 2029, 2030, somewhere in that region, actually put people up there. So that's the start of that. Quite aggressive. They've moved that up quite a bit. It used to be, I think, like 2035, and I think they moved it up. Certain amount of competition there in the US. Now, the moon base. ILR stands for International Lunar Research Station. It is an international effort, but clearly this is definitely Chinese run. I mean, there's not any question about that. I mean, even Russia is kind of a minor partner on the whole thing. And it's mostly countries that don't like us very much when you get down to it. So there's 2 groups in the space race. And this is one of them, and then the American-led one is the other one. What's interesting is you have some people that are also sort of US allies involved. The United Arab Emirates originally signed up for this. Remember, they had a rover in one of these earlier lunar missions that was supposed to land and go out. They were going to do that, and then people pointed out that, well, actually, the US embargo won't allow them to do that. So they may actually have pulled out. It's not clear what their status is right now. They may or may not be part of it. Turkey. Actually, they've changed their name for anybody who hasn't caught up with that yet. They got tired of being confused with an American bird, so they decided to change. This is actually the name in Turkish. Turkey, yeah. But anyway, they're applying, so it must take a while to get accepted. But they also would normally be considered a U.S. ally. One minor point is just that it's likely to be nuclear powered, the overall base, at some point. Not the first mission, but at some point. Realistically, that's going to be true for anybody, just because you need a lot of power. If you're going to start using resources on the moon, you're going to start melting regolith and that kind of stuff to get metals or even just to get water out of it. You're going to need a lot of power, and it's going to probably be nuclear. It seems like the best option. Now, they have a whole variety of things labeled 1 through 5. No doubt those will all change a lot. It's probably not worth spending much time. But there is an interesting point, though, and that's if you look at it, they're emphasizing, okay, lunar in situ research utilization technology. They're focusing on the stuff they really need to go there and stay there. So I think they're taking a much more, I would say, realistic approach toward actually being on the moon. And I'll contrast that. Now, I'm going to fall into opinion here. Not everybody would agree with this. Anything on this slide you can say isn't necessarily purely factual. What I say is there's kind of 2 space races going on. There's one for political and economic power, and there's one for prestige. And I say the Chinese are playing both of them pretty well. We're kind of focusing on the prestige, which is kind of the old-fashioned Apollo model, where we're going to show that we're the best by putting people on the moon, and we ultimately won that one. China, they do both, but they're kind of focusing on finding and exploiting resources, looking at what it's going to take to do the human habitation, and what they call strategic needs. And all this involves things like building materials, agriculture. They're focusing on doing a lot of this stuff. And then at some point, if fusion energy becomes a thing, helium-3 is going to be heavily involved in that. That'll all be worth a very, very lot of money. A lot of Chinese have been interested in that. It remains to be seen whether that's actually going to pay off. But anyway, it's been a big thing. On the strategic needs thing, you can read publications like the South China Morning Post. They interview these people in the space program, and they're pretty blatant about it. They just say the moon, or even the points along the way, like the L1 point between the two, which is strategic, that's just like the South China Sea. They want to occupy it, first, to make sure that nobody else can keep them out of it. Second, so they can actually tell people that they don't want anybody else coming into it. They pretty much said that pretty blatantly. They're not really keeping that much of a secret, but we're not paying that much attention to it. But anyway, so that's an issue. Now, NASA actually does look at all these things, the in situ resource utilization, how do you mine the moon, all that kind of thing. They are funding these studies, but it's not a major NASA goal or even a national goal, really, when you get down to it. Most of the funding is going for planetary science and astronomy kind of things, the space telescopes and probes to go to Jupiter and those sort of things. And those are all good science and everything. But the rest of the funding then is going to what's called the Moon to Mars program, which includes the SLS rocket. And if you sum that up, I think it's a fair summary to say that its purpose is first to do some short moon visits, and by short meaning like 5-day stays a couple of times. And that's practice for going to Mars, where they're going to go and stay for a couple of weeks and then come back. You look at all the Moon to Mars plans, that's pretty much what's there. That's come under a lot of criticism. There's a guy, Rick Tumlinson, who actually has characterized that as what we're doing are planning camping trips. And I think he's right. But that's just opinion. Not everybody would necessarily agree with it. But it's something to consider. Some in the military, the U.S. military, have worried about this. And that's why you see some rather bizarre things going on, like DARPA, the Defense Advanced Research Projects Agency. I mentioned them back in, I think, October or November. They are coming up with research to figure out everything that's needed for lunar infrastructure to really actually start building a civilization on the moon. The fact that they're doing it rather than NASA is kind of telling. I mean, it basically says the military is worried that the civilians aren't doing their job, and so they're going to help out. That shows you how bad things really are when it's necessary for the military to come up with things that really should be civilian kind of concerns.
Okay, getting back to just reporting the news. One difficulty with understanding the Chinese space program is that some Chinese launches are not publicized ahead of time, and the complete purposes of many launches are often not clear. That's partly because of the dual civilian and military role of many missions. We try to list every launch to space in the monthly space news, and a Chinese launch on March 13th stood out recently.
The next one was a Chinese one, the Long March 2C. They were launching some lunar satellites, apparently, into what's called a distant retrograde orbit. There were communications and navigations. This was not part of their published plan, the Lunar Exploration Program. And they really have been kind of mum. They admitted that whatever it was didn't go right. It was a partial failure because they got a launch, but they didn't go anywhere near the moon. They're stuck in low Earth orbit somewhere. But nobody really knows much about what this was, and it wasn't really part of their official plan. So we just don't know.
After talking about the Chinese lunar program, for contrast, we'll briefly provide recent updates on two of their competitors.
We've talked about these in the past, but there have been updates. So like the Japanese had the Slim lunar lander. That's the one that landed upside down. That's that computer-generated image there. None of these have radioisotope sources of heat to last through the lunar night. It's 14 Earth days worth of cold temperature. They can't do it unless you have some kind of a heater. Most of those Chinese ones had that, and so they could survive the night, and they've been going for a long time. Most of these newer ones don't. It turns out, actually, the U.S. doesn't have that much of these radioisotopes. It's been kind of a problem. It's hard to get it. And so most missions, they just don't bother. But they were just trying to demonstrate landing. So anyway, they managed to survive a first lunar night, barely. They managed to show some operation, but some of the stuff had started to fail. They survived the second lunar night, but even more of it failed. And so I was saying the last time, it's kind of like a zombie kind of a situation where, yeah, they're there, they're kind of half dead, half alive. This time, parts of the battery cells have degraded, and some of the temperature sensors stopped working. So it's on its way downhill. It probably won't last another night. Or if it does, it'll be in even worse shape. But anyway, it's impressive that it survived at all because it wasn't designed to survive the night. Another one that's on the moon is the Intuitive Machines one. That's the Houston company. They had the probe called Odysseus. They had entered a standby mode back in the end of February, and there was some hope that maybe they would wake back up. But they had the same problem. Without having the radioisotope heater, they just really can't survive the night. They didn't survive it at all. So that's over. They were the ones that landed. They were at kind of a 30-degree angle. As the guy showed during the press conference, they landed on a piece of blue plastic. Go figure. Okay, that ends my talk.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of National Space Society's North Houston chapter, and a link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.